Hello, my dear young budding chemists. I welcome you all to my first lecture. I am Dr. Anandita Bhattacharya from the Department of Chemistry, Christ College, Kanpur, associated to Chhatrapati Shahu Maharaj University, Kanpur. I'll be teaching you solid state chemistry, which is Unit 5 of BSc Part 1 Semester 2 Chemistry syllabus. So friends, we all know that matter exists in three forms. That is gas, liquid and solid. We all know in gas, the intermolecular forces is too less because my constituent matters are far apart, whereas in liquid molecules they are much closer. So the intermolecular forces among the constituent particles increase. Likewise, if I consider my solid molecule, this has very close constituent particles, which makes intermolecular forces very, very strong. And that is the reason that all solids have a definite shape and a definite volume, whereas liquids have definite volume but no definite shape, and gases have neither definite volume nor definite shape. Now, if we move ahead, what is solid? So here we know that solids have a definite shape, definite volume, and it is highly incompressible because it is having strong intermolecular forces. It is rigid, again, because of those forces. So it is having strong intermolecular forces, and all its constituent particles have a fixed position because they are very close to each other. As they are very close to each other, they cannot move. Their positions cannot change, and that is the reason their positions are fixed. So, the study of solids is very important. What is the crystal structure? How they are arranged? So for this, we have solid state chemistry, which is the physical chemistry which deals with the structure and properties of solids. So it is of two types. We have crystalline solids and we have amorphous solids. In crystalline solids, the particles are very much in an ordered fashion. They follow a particular fashion. Whereas in amorphous, they are haphazardly arranged. They are not following any definite pattern, and they can move from, layers can move from one place to another. Example is our supercooled liquids, which are these glasses. To explain you, I can take you to nature, the structure of a crystalline and amorphous solid. We all enjoy bhutta, but have you seen those bhutta? In some bhutta, all the corns are arranged in a haphazard pattern, but in some, they follow a very orderly fashion. We have a row of corns. So this is my amorphous example and this is my crystalline example. Nature gives us very good examples because chemistry is nothing but chemistry of real life. We are real life chemists. Now if I concentrate on crystalline solids, I can say that they are the building constituents and arrange themselves in regular manner throughout the entire three-dimensional network. They have a definite geometric shape with flat face and sharp edges. They are highly incompressible because of their orderly arranged units. Since they are arranged in an orderly fashion, they have sharp melting point, they are anisotropic, they have a definite geometry, they give X-ray diffraction bands, and example of these crystalline solids are sodium chloride, cesium chloride, sodium fluoride, etc. Now if I move over to the amorphous solids. Amorphous word is derived from a Greek word omorph, which means shapeless. That means they have haphazard arrangement of molecules and they are considered as not crystalline in nature. They are also known as supercooled liquids. They have no sharp melting point because it is haphazardly arranged. They are isotropic. They do not follow any definite geometric pattern and they do not give X-ray diffraction bands. And that is the reason they are considered to be non-crystalline. Examples are glass, rubber, plastics, etc. To sum up, we can say the difference between them. Crystalline is ordered arrangement, amorphous is your not orderly arrangement. They are anisotropic, they are isotropic, they have a sharp melting point, whether amorphous do not have any sharp melting point. Since they are in orderly fashion, they are both electrical and thermal conductors, whereas amorphous solids are not good conductors. They do not conduct electricity or heat, so they are non-conductors. Now, the study which takes us to the study of the crystal, which is the experimental science of determining the arrangement of atoms in crystalline solids, is known as your crystallography. Arrangement of atoms or molecules follows generally two types of packing properties. That is, one is your cubic, which is arranged in the form of a cube, and the other is the hexagonal. It is like the beehive structure. They fit in between the spaces. So we have a better packing fraction in this form, that is in the hexagonal form, rather than in the cubic form. To study this law of crystallography, we have three laws. First is law of constancy of interfacial angles. Second is law of rational indices. And the third is law of constancy of symmetry.